Okay, guys, for today, we're working on lesson 2.2b, solving quadratics using the square root property. And your instructional objective will be to solve quadratic equations using the square root property. And more importantly, to think about the conditions that allow you to use the square root property. So if you could get that written down in your notes. Okay, so let's move on. You were asked to match the problems on your assignment to the problems on your note page. So questions 1 and 2 came from window 1, and then questions 3 through 9 came from window 2. 10 through 16 come from window 3, and 17 to 23 are window 4. So just double check your answers, make sure you have that right. Okay, so as I mentioned, this should be a 100% review of things you have done in the past. We're just reminding you how to do it and making sure we brush off all your skills because we need it for tomorrow when we complete the square, which isn't such an enjoyable process. But if we can do this process, it does simplify things a little bit. Okay, so I'm going to take this off freeze so you guys can watch. Okay, so here we go. We're going to start with window 1, and I'll erase all of that. Okay, so here we go. First window is just reviewing information. When I ask you to simplify a square root in exact form, then I'm asking you to keep it in square root, but pull out the perfect square. So you tell me, what's the biggest perfect square in 20? 4. So we could write it as a square root of 4 times 5, and then simplify that to 2 square roots of 5. Okay, and I put that one up there because it may appear often over the next couple of weeks. The next one was the square root of 50, and the biggest perfect square in 50 is? 25. Nice. So 25 times 2, and the square root of 25 is 5. So 5 square roots of 2. And then the last one, these basic ones that you can just pretty much do in your head. You have the square root of 75. The biggest perfect square in that is 25 times 3, and the square root of 25 is 5, and square roots of 3. So just remembering how to simplify square root. Thankfully, they're not cube roots and fourth roots, etc., and you don't have a bunch of variables tucked in them. But just reiterating that this skill keeps coming back around. It keeps coming back around. And hopefully every time it comes around, you're getting better at it. You're getting faster at it. You're becoming more accurate. Okay, so there's that. So there was that review. And then in the other problems that you had to do, what were these ones? All right, so what we have here is a fraction. It's not a pretty fraction, but the rule for fraction, and that's not a negative 9, by the way. The rules for fractions are that you must always simplify them if you can. Sometimes people really struggle with simplifying fractions that look like this, where in your numerator you have a number, but you don't know what that number is because it's separated into 2 different quantities. But you know your denominator is 9. So I think what I would like to do to illustrate why I'm about to do what I'm going to do, I'm going to change this problem and give you a different example. You don't have to write this down. I just would like you to watch. That is also a fraction. Do you agree? A single fraction with a binomial in the numerator and a monomial in the denominator. And if I want you to simplify that fraction, I want you to keep it as a single fraction, not write it as separate fractions. So when I am simplifying a fraction with a binomial, different sized terms in the numerator and denominator, what I like to do is show my fractions some love. Show us some love. Some teachers just draw triangles, but hearts are cuter. So what you do to simplify this is you have to use the greatest common factor. In this case, the greatest common factor would be a. So we would reduce it to 2 plus y over 4, right? And that is as simple as you can make that fraction. So when we come back over here, that same idea applies. The square root of 3, PS, is not a whole number. Okay? It doesn't have common factors with these three numbers. So what I'm going to remind you of is that we are going to show some love. You can use a triangle if you want. No, you don't want to be girly like me. It's okay. We have to make sure we can't simplify this fraction. So what's our GCF? So let's reduce them all by 3. That would be 1 minus 9 square roots of 3 over 3. And just be really careful not to try to reduce the square root of 3. Because if you plug it in the calculator, it's like 1 point something something forever and ever, amen. Okay? You can't divide it by 3. Okay? You do the next one? You do the next one. Okay, did you find it? Your GCF is? So you reduced it down to? -1 plus or minus 5 square roots of 2. And I bet you didn't write it over 1. Well, if you did, I bet you're thinking, why did I do that? Okay? Oops. That's okay. But of course, the most simplest form would not be to put the 1 under there. Right? So that will happen sometimes. It won't happen very much today, but tomorrow it'll happen often. Okay, so moving on, now that we've reviewed just our simplification of our square roots and our freaky fractions, we're going to move on to applying the square root property. So we're going to start off with the definition of the square root property that says, if C is greater than 0, meaning it's positive. Yes, everything greater than 0 is a positive value. The equation, that should say equation, not equations. X squared equals C has 2 real solutions. Or roots. My preference would be roots, but it doesn't matter. And the roots are, the real solutions are x equals the square root of C and x equals the negative square root of C. Okay, so that's the definition of the square root property. Notice that there's no b. Okay, you have your x squared term, and you have your c term from your quadratic, but there's no b term. The format has to be as follows. The quantity squared equals a positive number. These are the conditions that I was talking about in your objective. The conditions must exist that you have a quantity squared equals a positive number if you want to apply the square root property to solve a quadratic equation. Okay? So give me an indication of how much more time you need to write that down. 2 minutes? Don't tell me 2 minutes. 30 seconds. That's what you got. Go. Okay, ready? Yes. All right, so we're going to start off with our most basic problem here. A squared, I'm going to get it right here in a second, equals 81. And so I'm checking for conditions. Is the left side a perfect square? Yes. Is the right side a number? Well, I am waiting for this bunch of hoo-has to settle down. We good? Yes. Okay, then I can apply the square root property that says if I want to get rid of a square, I square root it. But when I take the square root of a number, I have to grow up now. And I have to remember that it has two answers. The principal square root, which is your positive square root, and the negative square root. Because isn't it true that a could equal positive or negative 9? Like negative 9 times negative 9 is positive 81. And 9 times 9 is 81. Now, I'm going to be a stinker, and I'm going to say write it in solution set and separate it. Two separate solutions or roots. And if I had to go graph them on a number line, when I'm graphing a parabola, I can find them quickly. Okay, let's do the next one. We have another one that says this, 3n squared equals 150. And the first thing I'm going to ask you are, do the conditions exist for me to apply the square root property? Do I have a perfect square on the left-hand side and a number on the right? No. What's wrong? There's a 3. It's not a perfect square, right? So if we want to apply the square root property, we've got to divide that 3 to the other side. So we get n squared equals 50. Now our conditions exist so that we can apply the square root property. So the square root of n squared equals plus or minus the square root of 50. Then, of course, we would simplify that to plus or minus 5 square roots of 2. And then, of course, write it in solution set, and I'm out of room. Negative 5 square root of 2 and 5 square root of 2. So that should be total review. Yes? We have all done this before. Okay, so let's move on now then to our intermediate window where things sometimes aren't quite so obvious. Here we have the quantity x squared plus 4 equals 79. And here's where I'm going to start catching people not being careful or not knowing the actual truth. Here's my question. Do the conditions exist where I can apply the square root property? Is the left hand a perfect square? Okay, I'm hearing yes, and I'm hearing no. The answer is no. X squared plus 4 is not a perfect square. Here's a perfect square. X plus 4 quantity squared. Now, that's a perfect square. But I can't factor this into a perfect square. So you know what I have to do first? Move the 4. So x squared equals 75. Now we are 100% sure the conditions exist so we can apply the square root property. I think I'm going to sit down. Okay, so we get x equals plus or minus 5 square roots of 3. Of course, we'll write it in solution set. Okay, and then we have one more. And again, I'm trying to challenge you to think about this problem. Do the conditions exist so that the left hand's a perfect square and the right hand's a number? Well, that's a negative 9. I don't think negative 9 is a perfect square because it would take a negative 3 and a positive 3. And if I were to factor that out, please don't write this down, but if I was to factor it out, it'd be the difference of squares. 5p minus 3 and 5p plus 3, and that's not a perfect square. They're different. They're conjugates of each other. So it's not a perfect square. What should I do? Move the 9. So we have 25p squared equals 18. Now there's two ways I could go about this. The conditions now exist so that I can square root both sides. Or if I wanted to, I could move the 25 first. I tend to not like to complicate the right-hand side and turn it into a fraction unless I have to. So I would suggest taking the square root of 25p squared and positive and negative version of the square root of 18. And let's simplify the square root of 18. It's the biggest perfect square in 18.
9.
So that'd be a square root of 9 times 2. So simplify it. 3 square roots of 2. Okay, and so we took the square root of 25p squared. We have 5p. Now let's divide. And we get p equals, I'm going to just do my solution set, negative 3 square root of 2 over 5 and 3 square root of 2 over 5. Then let's just make sure we don't have to simplify that. Can we simplify 3/5? Nope. Okay. So there you have those solutions. Okay, so those would be more intermediate level where you just kind of have to engage your mind a little bit and make decisions. Are you going to move the 25 first and then square root, or are you going to leave it there? You can make that. You have the power to make that decision. You do what works for you. Okay, let's do the last ones. So our brain engaging window. Here we have some that are just not quite as obvious in structure. So here was our first problem. And do the conditions exist for us to apply square root property? Definitely not, right? So what should we move at least first? Okay, so I'm going to add 125 to that side. So we have 5 times quantity x minus 2 squared equals 125. Any other manipulating I need to do? Divide by 5, because 5 is not a perfect square. So now we have a quantity x minus 2 squared. Excuse me. Sorry. Equals 25. Well, that's looking pretty now. I'm liking it better. Do our conditions exist? Quantity squared equals a number. So we'll apply the square root property. Some of you will just write plus or minus 5 at that point, probably. But that's okay. So we simplify that to x minus 2 equals plus or minus 5. Now I'm going to get picky. Okay, so please pay attention. We're going to isolate the x by adding 2, but I would really like you to scoot that up front. It's the proper placement of that 2. So we're going to do x is equal to 2 plus or minus 5. And when we get this situation, we're going to get two answers that don't look the same. So we're going to go x is equal to 2 plus 5 and 2 minus 5. And then, of course, we'll simplify that to 7 and negative 3. Okay? Sometimes you got to finish it out because you can combine them. They're like terms. Do you have questions before we move on to the last one? Yes. I did 2 plus 5, which is 7. And then I did 2 minus 5, which is negative 3. Does that answer your question? Jacob? No, of course not. But in your notes, it might not be a bad thing to have just so that you can reference it. If you can see it, you can see it. It's not like those are hard problems to solve, right? Probably wish all your homework was that easy. No, you wouldn't learn anything. Last problem. Okay, so here we have this beast. Does anybody have anything to say to me about this? What? No, because you can't get a 7 out of the 25. If you go back to my definition of the square root property, I said notice something. What did I say? There's no B term, right? But you know what I see? A B term. But I always put myself on alert when I'm factoring a trinomial. So I'm going to have to bust out my factoring skills. Is this a perfect square trinomial? Square root of that? Is that a perfect square? Is that a perfect square? Let's bust it up. So the square root of 49, a squared is 7a, and the square root of 25 is 5. Now, to get the middle term, we need 2 of these. 35, 35. Isn't that 70? What sign should I use? Guess what it is? A perfect square. What? Got to train yourself to see it. Otherwise, you'd have to complete the square or use that ugly old quadratic formula to solve this problem. It won't factor if you incorporate the 54. It won't. So you either see it or you don't, and that doesn't matter because you'll get to the answer some way. There's 4 ways to solve a quadratic. But now we have the conditions. I gave you some to practice so that you'll start noticing it. So we'll square root that. And plus or minus the square root of 54. Okay, 54. Does it have a perfect square? Let's simplify it. 9 times 6? Square root of 9 is 3. So 3 square root of 6. That's not a 6. 6. Okay, so now we have 7a minus 5 is equal to plus or minus 3 square roots of 6. Now, we have to start moving these numbers over. So we'll add 5 to the front. I'm going to write it over here. So we have 7a equals 5 plus or minus 3 square roots of 6. And then we divide both sides by 7. And we get a is equal to, and I'm going to separate them. First of all, do we need to give it love? Can I simplify 5, 3, and 7? Yeah. They're prime, right? Okay, so 5 minus 3 square root of 6 over 7, and 5 plus 3 square root of 6 over 7. And again, this should all be a review. I'm just reminding you how to place things where they go when you're writing your solutions. Wyatt, how can I help?
When 5 minus 3 and 5 plus 3, is it okay if you like combine like terms?
No, because they aren't like terms, actually. But I thank you for asking that question. I would suggest that you plug the square root of 54 into a calculator and see what it equals. Because you're doing 5 plus the square root of 54, and then you're doing 5 minus the square root of 54, and they are not the same kind of numbers. So you can't combine them because they're not like terms. This is irrational. This is rational. We can't add that. Good question. All right, I'm going to shut this video down. So bye, folks that are listening to the video. Have a good day.